right, so a polynomial is made up of monomials. It's basically the sum or the difference of monomials. So what we have here are some examples. The first one is made up of 1, 2, 3 monomials, and we're adding them, so that would be a polynomial. The second one, would this be a monomial or a polynomial? This is definitely a monomial because there's only one term, and even though we have a number and a variable, they're being multiplied together, which makes it a monomial. Is this a monomial or a polynomial? We have 1, 2, 3, 4 monomials, and we're adding them, so this would make it a polynomial. Now, when we are talking about polynomials, because they're made up of monomials, we are going to still be looking at degrees and coefficients. We usually call the first monomial the first term. The second one would be the second term, and so on. So let's go one by one in identifying first, second, third, fourth terms, degrees, and coefficients of each. Now, let's start with x squared plus 2y squared. Let's start with this one. Our first term in here is x squared. When we look at x squared, our degree is 2 because that's our exponent, and our coefficient would be a 1. Now when we look at our second term, that would be 2y squared. The degree here would be a 2, and the coefficient here would be a 2. Let's look at the second expression here. Our second expression is a monomial. So we only have one term, and our term is 5c cubed. The degree of this term would be our exponent, which is 3. The coefficient here would be a 5. Go ahead and try to do this one on your own. We have a degree of 1. If you remember, the degree of a term is a degree of the sum of the exponents in your variables. So in here we have an exponent of 1 and an exponent of 1. So our degree for this particular term would be a 2. So what you'll see with polynomials is that if they have the same variable, we want to always write them with the highest degree on the left to right. Now these ones happen to have more than one variable, so the rules are a little bit different for that. But if I had x to the 5th plus 2x squared plus 3x to the 6th power, what I would have to do here is I would have to organize this. All the three terms in this expression have the same variable, so I would have to look at the degrees of each variable and put them in order. So I'm going to have my highest degree, which is x to the 6th power. I'm going to have that write it first, and then I'm going to order it like this so that my x to the 2nd power, which is the smallest degree of exponents that I have here, would be the last one, and my x to the 6th power would be the first one. Now that is individual terms, but when I look at the whole expression, the whole polynomial expression as a whole, if I were to be asked what is the degree of this polynomial expression as opposed to what is the degree of this one term, my answer is going to always be the degree of the monomial with the highest degree. So the degree of this polynomial expression is 6 because I look at the term with the highest degree, and that is the first term in here. So that's why it's important to organize your monomials in your polynomial when they have the same variable from greatest to least.